started. It's a few minutes after. People can roll in during the introduction. So thanks everybody for joining us today for the Rotor Safety Masterclass. Our goal today is to help you improve your lab safety, maximize your investment, and extend the life of your equipment. Our Beckman speakers will present for about 20 or 30 minutes, followed by a Q&A. Please feel free to drop your questions in the chat at any time during the presentation. After the session, we'll email all attendees additional rotor safety resources. A quick word about who's hosting today. Laboratory Equipment Company is the West Coast's concierge service for scientific discovery and innovation. Since 2019, we've proudly partnered with Beckman Coulter to provide expert equipment guidance and hands-on support throughout the life of your instruments. Beckman Coulter has been advancing science since 1935, delivering trusted centrifugation and cell health technologies to help researchers accelerate discoveries and find answers that matter. Today, we're excited to be joined by speakers Natasha Broski and Nathan Katz. Natasha is a senior project manager at Beckman Coulter. She oversees the Avanti, Allegra, and Microfuge centrifuge lines. She brings valuable application expertise from her genomics background. Nate is the Northern California representative with Beckman Coulter. He helps lab improve performance and promote safety and confidence centrifugation practices. And I'm Britta Johnson. I'm your moderator, Vice President at Laboratory Equipment Company. I've been supporting life science laboratories in the San Francisco Bay Area for more than 30 years. Before we begin, we're going to launch a quick two-poll question, and you'll have a few seconds to answer. And at the end of the presentation, we'll review the results with everybody. So the first question, you should see the poll now on your screen. And the first question is, how old is your oldest rotor? And the second question is, how often does your lab check rotors for signs of wear? We'll leave the poll open for a little bit. And Natasha and Nate, if you want to go ahead and just start, we can do that, and I'll close the poll here in a few seconds. You're on mute.
All right. Thanks, Britta, for that kind introduction. I'm excited to be here today to talk about rotor safety, an often overlooked area that's critical for both the performance of your centrifuges and the safety of everybody in the lab. This presentation will walk you through why rotors fail, the proper use and maintenance, rotor retirement, and we'll end with our field rotor inspection program. So let's dive in. First, let's take a moment to think about what a rotor actually goes through. During operation, an ultracentrifuge can experience up to 1 million times the force of gravity. To put that into perspective, 1 gram of material, basically a paperclip, effectively weighs 1,000 kilograms, the same as a Volkswagen under these conditions. So with forces this extreme, even the smallest imperfection in a rotor can become a serious problem. These stresses can sometimes quickly exceed what the rotor was originally designed to handle, which is why proper maintenance, inspection, and usage is so critical for both safety and performance.
Thank you, Nate. Up next, I'll be talking about why rotors fail. One of the main factors that contributes to rotor failure is stress. During operations, the forces acting upon a spinning rotor create stress in the metal of the rotor. This causes the rotor to stretch and change in size. Figure 1 shows the relationship between these forces, called stress, and the stretch, called strain, in a typical rotor alloy. You can think of a rotor as a giant spring, which stretches and then relaxes as forces are added or removed. Our rotors are designed to operate in the red region of the graph on the left, where the rotor alloy is elastic and capable of returning to its original shape after a run. Our specifications, such as maximum speed and maximum sample density, work together to ensure that the forces on the rotor remain within the acceptable limits of the rotor material. If a rotor is used outside of these specifications, such as running at a higher speed or with heavier or uneven loads, the rotor could permanently deform, entering that black area of the graph. If a rotor deforms or stretches far enough, it can reach its fracture point and ultimately fail. For this reason, it's important to always observe the limits of your specific rotor and never to run a rotor that has visible damage or deformation. Another factor that contributes to rotor failure is metal fatigue. After a certain number of stress cycles, or cycles of stretching and then relaxing, metals lose their ability to recover, suffering what is called fatigue. For rotors, we consider one cycle to be accelerating up to operating speed, maintaining that speed, and then decelerating to a stop, one stretch and relax cycle. Over a period of many of these cycles, the stretching and relaxing of the rotor leads to microscopic changes in the structure of the metal. With repeated use, these small changes accumulate, causing microscopic cracks to grow into larger cracks that can eventually lead to rotor failure. This is why we limit the recommended lifespan of our rotors. Finally, the last factor that contributes to rotor failure is corrosion. Corrosion happens when a metal surface is attacked by moisture, reactive chemicals, or alkaline solutions like cesium chloride and other salts. These substances eat away at the surface metal of the rotor, forming pits. These pits then reduce the amount of metal available in the rotor to handle the stresses of operation, effectively eating away at the spring that is the rotor. In addition to surface corrosion, rotors can also be subject to a unique phenomenon called stress corrosion. When spinning at high speeds, stress cracks can develop at the pits left by surface corrosion. If the corrosive agent is still present, it can then infiltrate the crack and attack the newly exposed material. This weakens the metal further, causing the cracks to expand, and the stress corrosion cycle starts all over again, eventually leading to the failure of the rotor. Figure 2 on the right shows a cross-section of a corroded aluminum rotor, with pits highlighted by red arrows and visible cracks radiating from these pits. It's very easy to see the large crack on the left, but if you look closely at the other pits, you'll notice that there are some microscopic cracks forming beneath those as well. Aluminum rotors are particularly susceptible to chemical corrosion. In fact, stress corrosion is an aluminum rotor's worst enemy and is the most common cause of failure for aluminum rotors, especially as they age. Stress corrosion will cause failure sooner and at much lower level of stresses than if the rotor were undamaged by corrosion. In this next section, we'll share some critical ways to prevent this common form of rotor damage. Hi, Nathan. It appears you're on mute still.
Oh, thanks, Natasha. Now that we've gone over the main causes of rotor failure, I'll talk a little bit about how to properly use and maintain your rotors to avoid such failures. The first and somewhat obvious tip is to always observe the load and speed recommendations for each rotor and double check the manual before creating your protocols. All rotors are designed to carry a maximum load and a maximum speed, so be sure to follow all the operational specifications found in your rotor manual, as even one run made under these excessive stress conditions may significantly reduce the life of your rotor. We have multiple formats for the rotor manual. You should receive a hard paper copy with the purchase of a new rotor, and it's best to have it stored near the centrifuge for reference. The rotor manuals can also be found online on our website by searching for the rotor model and looking under technical documents. This is often an easier way to look up information in the manual with a control-find search. Alternatively, you can always reach out to a Beckman or LEC service or sales rep who can help you find the answer you need. For swinging bucket rotors, you want to ensure that all the buckets are used and that the samples are properly balanced. And for fixed angle rotors that use carbon fiber canisters, you also want to ensure that all those canisters are used and also properly balanced. Paying close attention to setting the run speed is crucial. Most of our new centrifuge models have rotor detection technology that will actually prevent users from setting run speeds over the max rated speed of the rotor. But when using our legacy models, this is something to pay very careful attention to. Also, certain labware and adapters have their own maximum speed restrictions as well, so make sure that you double check the required speed reductions when using any adapters or abnormal tube types. You can have a rotor that reaches up to 50,000 xg, but if you're using adapters that require a speed reduction of 40,000 xg, you need to make sure not to set it higher. All of this information can also be found in the hard copy manual that comes with your rotor, as well as our online manual from our website. And again, if you're unsure, you can always reach out to your local reps. All of our ultracentrifuge rotors have overspeed discs, and all of our high-performance floor rotors have magnets which prevent the rotors from exceeding its maximum rated speed. This is especially important in these models as they can reach very high g-forces. The users should always make sure that the discs and magnets are properly installed and in good condition, and this can also be verified by a service engineer visit. Now let's take a quick look at different materials rotors are made from and how that influences the way that we handle and maintain them. Titanium rotors are the most resistant to corrosion and are recommended if the rotor is going to be used with corrosive salt solutions such as cesium chloride density gradients or potassium bromide and even PBS. However, the rotor still contains small aluminum parts which are still susceptible to corrosion, so it's important to keep an eye out on these parts to see if they should be replaced. You can always send a picture or let a service engineer know during a visit to take a look and advise. Aluminum rotors, while a bit cheaper than titanium rotors, are more susceptible to corrosion, especially from alkaline solutions like sodium or potassium hydroxide or other high pH buffers. So if you're working with corrosive salts or high pH buffers, titanium rotors are going to be worth the investment for longer lifetime usage. When cleaning aluminum rotors, you want to make sure that you're only cleaning with the special plastic-coated brushes, as to not damage the coating, which can create a site for stress corrosion to begin. And also washing any components in mild detergent, such as the Beckman solution 555, which will not damage the coating. Please do not use any alkaline or high pH detergents or cleaning products like bleach, which may remove the coating. Being gentle with the coating will ensure that your rotor is less susceptible to the corrosion and will increase the usable lifetime of the rotor. If you have run or spilled any corrosive materials in the rotor, you want to wash it immediately with the cleaning solution, as well as any buckets or fixed angle rotors used with open tubes, as any salt buildup will corrode the metal. Don't forget the hanger mechanisms on the rotor as well, as this can rust without proper cleaning. After the rotor has been cleaned and thoroughly dried, you should continue to air dry all the components facing down. And after cleaning, you also want to remember to properly lubricate the pins and buckets for any swinging bucket rotors as mentioned in the care and maintenance section of the rotor manual. The lubricant should come with the new rotor, but if you need more, you can always let us know. In terms of storing rotors, you want to make sure that there is no moisture or other contamination present, as this can be a source of corrosion too. All the swinging bucket rotors and buckets and fixed angle vertical tube rotors should be stored upside down in a dry environment with any caps removed to prevent moisture buildup. And please do not leave your rotors stored inside the centrifuge. When the time comes to use your rotor, you want to double check the classification of the rotor and the centrifuge you plan to use and ensure that it matches. The rotor centrifuge compatibility is a function of the rotor chamber size, overspeed protection, chamber doors, and barrier ring. If you are unsure of a compatibility, you can check the centrifuge manual, which will have a list of all compatible rotors, or reach out to your local sales or service representatives, and we'll be happy to check for you. And finally, and one of the most important points, is to not use your rotors past their expiration dates. Most of our rotors and rotor components, such as canisters and labware, have the serial number with the manufacturing date marked in the rotor itself. This helps to identify how old the rotor is and when it should be retired. Each type of rotor has its own expected lifetime and can be found in the rotor manual and also in our rotor safety guide, which we'll be sending out after this webinar. It helps to keep the purchase date of the rotors on file so that you know the age. We actually test how many cycles and how long a perfect condition rotor can spin before it fails, so these expiration dates are from real data on how long these rotors last before showing signs of failure, further highlighting the need to follow the proper retirement dates. You really don't want to be spinning a rotor past its expiration date.
Thank you, Nate. In this next section, I'll be covering rotor warranty and retirement. With use, even the most well-designed and well-maintained rotor will eventually reach the point where it could fail during operation. As we spoke about earlier, corrosion, stress corrosion, and metal fatigue, which can be invisible to the naked eye, eventually take their toll. The next slides discuss warranty years and rotor retirement information for Beckman Coulter Life Sciences rotors. As I covered during the why rotors fail portion of this presentation, due to metal fatigue, it's important to retire and replace your rotor when it nears the end of its recommended life. Fatigue life precautions are built into our specifications for the rotors, and our centrifuges were designed with the worst case scenario in mind. In the rare event that a rotor failure does occur, our ultracentrifuges are designed to contain the physical destruction that could occur from an ultra-high-speed rotor failure. Likewise, our high-performance centrifuges have been designed and tested to ensure a normal fatigue life that extends well beyond the number of cycles that could ever be run during the rotor's recommended lifetime. However, these extra safety measures should not take the place of careful retirement practices. Even if the damage is contained, a rotor failure can mean the loss of valuable samples and a severely damaged instrument, a gamble that could be very costly for your lab. Recommended retirement by rotor type and a rotor warranty example are shown in the next slides. This slide lists our warranty period duration, the recommended retirement age, and the maximum number of runs recommended for each of our rotor types. This table will go out in the rotor safety guide after this presentation. In general, our warranty period covers issues arising from defects in rotor materials or workmanship. It does not cover failures arising from misuse or mishandling. A rotor's configuration, material, and maximum speed all play a role in determining its safe and useful lifespan. The warranty information for your specific rotor can be found at the end of the user manual. An example is provided on this slide, which shows details such as the condition of our warranty and our repair and replacement policy. One important thing to note is that we warrant our rotors and centrifuges against the defects in materials and workmanship, and we may choose to repair a rotor at our discretion if it's within its warranty period. However, this warranty is based on the concept of a Beckman Coulter Life Sciences designed and tested rotor and centrifuge system, in which the characteristics of the rotor, the drive, the centrifuge, and the containment have been carefully matched to ensure safe operation. We cannot warrant our rotors when they're operating in other centrifuges, and we do not warrant our centrifuges when used with other manufacturers' rotors.
All right, and now I will wrap up the presentation part by talking a bit about our Field Rotor Inspection Program, or FRIP program. Our Field Rotor Inspection Program is available to owners of all Beckman ultracentrifuge and high-performance Avanti rotors, and was developed to help labs prevent rotor failures by identifying early signs of stress corrosion, metal fatigue, and coating damage before they become safety risks. A specially trained Beckman representative comes on site to examine your rotors, checking for expiration, wear, or other concerns. If issues are found, we'll provide clear recommendations, whether that's continued use, repair, or replacement, so that you can maintain compliance and avoid costly downtime or other safety issues. If you'd like to schedule an inspection, simply reach out to your local LEC or Beckman Coulter service or sales representative. And finally, I want to thank you all for attending today's presentation. I hope that you now feel more confident about how to properly care for your rotors and when it may be time to retire or replace them. With consistent care and good lab practices, your rotors can provide a long, safe, and reliable service life. If you have any questions about rotor care or would like to schedule a FRIP visit, please don't hesitate to reach out to your local representatives. Thanks, and with that, I'll hand it back over to Britta.
Thanks, Nate and Natasha. I'm going to share the results of the survey now. Everybody should be able to see that. Just an interesting snapshot of how old the rotors are that people have. Actually looks like, we've 35% of people still have some fairly young rotors. And then how often people check the rotors for signs of wear. So it sounds like this FRIP program might be great for 30 to 48% of the people, 78% of the people on this call. And that FRIP program, is that something that customers, do they pay for that, or how does that?
Yeah, the FRIP is actually going to be free of charge for all of our customers. So if you do have some rotors and you want us to take a look, just let us know and we'll come out there.
That's great. Great. Okay. Well, we can get to some questions now. Thanks, everybody. Let's see. I'll start with where can I find the date of manufacture on my rotor?
Sure, Britta, I can take that one. So if this talk has galvanized you and you're ready to go out to your lab and check the dates on your rotor, one of the first places that you'll look for information stamped on your rotor is right there at the top. Oftentimes you can find that date of expiration on the lid. You might also, if you have canisters or swinging buckets, check on the front side or rotate them a little bit to find that information stamped right there. If you look at your rotor and you only have either a serial number or a date of manufacture, you can use the table that we'll be sending out in the rotor safety guide after this presentation to look at that date of manufacture and compare it to the lifetime of your rotor to see if it should be considered for retirement. And if you only have a serial number, you can certainly reach out. We'd be happy to help translate that to you to figure out when your rotor was manufactured and how old it is currently. So please feel free to reach out to our tech support team or any of the sales folks as well in your area, and we'd be happy to take a look.
Great. How do you know what metal your rotor is made from?
Ooh, that's a fantastic question. I can take that as well. So we have rotors that, as we mentioned, are made of aluminum, titanium. If you have a much smaller centrifuge, you might encounter a plastic rotor. Usually the plastic rotors will be pretty obvious. They'll be much, much lighter. They'll usually appear tan or beige. But if you're looking at what you determine as a metal rotor, it's heavy, it's weighty, and it's either anodized in blue, black, red, or green. You can start by looking at the name of the rotor. Usually if it's titanium, the rotor name will end in the letters TI for titanium. And if not, you might look and check the rotor user guide, which lists under the specifications what material your rotor is made of. And that will also include information, if you have a titanium rotor, which components specifically are aluminum and how those components need to be cared for. And again, if you have any questions, please don't hesitate to reach out to us.
Great. Okay. How long do rotors last? There's kind of two that are sort of similar. How long do rotors last? And how long how does Beckman determine rotor expiration dates? Kind of dovetail. So,
Sure, absolutely. So again, the table that we shared in the slide deck will be going out in the rotor safety guide. So that lists the expected lifespan for each of the rotors, and you can reference that. And again, in the rotor user manual itself, it will also list the age and instructions. I think I also saw a question about rotor derating based on age for certain ultra rotors. That information is also in the rotor manual. So again, if you have your rotor manual handy, you can turn there or you can go to our website at beckman.com, find your rotor manual under our technical documents, and then do a keyword search for age or retire. And those keyword terms should get you the information pretty quickly. The second part of the question that I heard was, how do we determine rotor life? As Nate mentioned during the presentation, we test our rotors to determine their useful lifespan, and then we base our recommendation on a safety factor reduction from the lifespan that we experienced. So we do a combination of materials modeling, machine analysis, and then actual failure analysis within our systems to make sure that we have the best recommendations for operational life and safety of our users.
great. So, another two questions that are similar, both asking about, is it okay to store your rotors in a cold room 24/7? Is it good lab practice to store ultracentrifuge rotor and buckets in the cold room? So, two questions, probably similar answers. So,
Absolutely. So the advantage of the cold room is that when you get your rotor out of a cold room, it's already cold. And so you don't have to pre-chill a rotor in the centrifuge itself. But the challenge with a cold room is that the humidity can often be very high in some of those environments. And in a high humidity environment, you're more likely to have those rotors corrode. This is maybe a little bit less of a problem for some of the titanium rotors, but it is worth evaluating whether your procedures can allow those rotors instead to be stored in a dry place. And then instead, you can use the centrifuge to pre-cool that rotor right before you're ready to do the run. So take a look at your protocol and see if that is maybe a possibility or an option for you. And take also a look at the material that your rotor is made of. If it's an aluminum rotor, then I would perhaps suggest not storing that long term in a cold room. And also, if you are going to be storing in those conditions, if you have to have your rotor ready to run when you're ready to run, it may be worth having our team take a look at your rotors and inspect those regularly for signs of wear or corrosion.
Okay. And we've got a raised hand here on. I think I can, oh, nope, I guess not. You can always type on if you want to type your question in the Q&A. That's great. So we'll keep working through the typed questions. You mentioned, and this kind of goes along with the storage, you mentioned not to store rotors in a centrifuge. Does that include floor centrifuges? Must rotors be removed after each use?
Thank you. Yes, we typically recommend that rotors are not stored in the centrifuge. If you are speaking specifically about some of our higher capacity rotors, for example, if the term JLA 8.1000 or JLA 9.1000, if you're using a very large liter scale capacity rotor, we certainly have had customers that have stored the rotor in longer. That rotor is composed partially of aluminum components and partially of carbon fiber components. And what we typically recommend for those customers is to, again, do regular checks to make sure that that's not negatively impacting the rotor life, so that there are no signs of corrosion, etc. If you're storing the rotor in with your centrifuge lid open, for example, and allowing good airflow, if you're making sure that the system is dried after every use, then you might not experience some of the corrosion, et cetera. But if you're running frequently, if it's a high humidity environment, if the chamber is not being vented afterwards, et cetera, then it could be a much better practice to store that rotor outside to make sure that you are able to realize that full rotor lifespan and that lifespan is not reduced by moisture causing corrosion, et cetera. So yes, we do recommend that whenever possible, rotors are stored outside of the centrifuge. But we do understand that for the heaviest rotors, there are certainly some tips and tricks that you can use to avoid having to move those so many times.
Great, thanks. Okay, here's a little long one. We have some aluminum rotors and many titanium ultra rotors. Recently, carbon fiber rotors have begun to infiltrate our collections. I don't know if any of these rotors are manufactured by Beckman. Are there other failure modes or an accumulating use history that would indicate how to inspect these, as they don't seem to show corrosion? Do you still inspect all rotors when preventative maintenance is performed on the ultras? Do rotors still get derated based on age? Three-part question.
Certainly. All right, let me make sure I've got that pulled up so that I can look at each of these.
Yeah.
All right, so the first part of the question is about carbon fiber rotors, and some of our larger capacity and higher speed rotors for our Avanti models are partially composed of carbon fiber, but usually Beckman will have a discrete component of those, typically the canister, and then we'll use aluminum to sort of hold those canisters in place. And that's why you'll see an expiration date or a manufacture date on the rotor itself, those aluminum components, and you'll see a separate expiration date or manufacture date on the carbon fiber components. So you do need to check both of those places. If you're referring to rotors that are fully carbon fiber, you're probably thinking about some of the rotors that are available from our competitors, such as Thermo Fisher Scientific, which of course I can't speak to as much, but from our own expertise and knowledge, we've certainly heard from customers that these can be much more susceptible to breaks from dropping, etc. When we perform our FRIPs on our rotors, we could potentially take a look at. We have, of course, the fiber optic borescope at some of those at the other rotors, but we really can't speak to the safety and the lifetime of those rotors. You'd have to reach out to the representative of the company that manufactured those specific rotors. But I would caution that, again, they're similar to similar I would say weaknesses that may not be visible to the human eye. So absolutely, you should also keep an eye on those rotors as well. Let's see, what was the other part of
It
that
was
question?
preventative maintenance is, I mean, I think it's to sort of interpret it. Do you recommend that customers still inspect their rotors even when preventative maintenance is being performed, especially on ultras?
So best practices in your laboratory would be to set a regular cadence for inspecting your rotors. Ideally, we'd have rotors inspecting each, pardon me. Ideally, we'd have users inspect rotors before each use, since again, by the time some of those stress points are visible to the naked eye, it's really starting to become a concern. So please do notice and try to take note of your rotors. But it would be helpful to schedule a regular inspection by your team just to review the expiration and manufacture dates. And then, of course, when our field service engineers are on site for preventative maintenance, et cetera, you can absolutely have them take a look at the rotors. And if you have any serial numbers that you're not sure what the date of manufacture is, they can also provide information at that time as well.
Okay. And the last part of this question is, do rotors still get derated based on age?
Yes, and I think they answered that a little bit earlier, that you'll
Okay.
refer to the user manual for each individual rotor. Yes.
Okay. Okay, great. Why is the number of runs listed as a limiting factor for rotor life, but run length is not?
Sure. So during acceleration and deceleration, those are the periods in which the forces, the amount of forces are changing. And so those are the phases during which the rotor is sort of expanding and contracting, the sort of points at which the spring is moving. And so those are the highest stress events. We know that an object in motion tends to stay in motion, an object at rest tends to stay at rest. And when a rotor's at or maintaining speed, the sort of forces in the system are constant. So it's the time periods of changing forces, that acceleration and the deceleration, that really are fatiguing to the metal. And so that's why the lifetime is typically listed as number of runs rather than duration of run.
That makes sense. And do I have to schedule a FRIP or can I ask the tech to check my rotors while they're here for a PM or another scheduled visit?
You could certainly ask your field service engineer to check while they are on site. But if you schedule a FRIP, they're more likely to be carrying the fiber optic boroscopy equipment at that time. So
Yeah.
certainly you can have them check serial numbers. You can maybe have them visually look over. But if you want a more detailed examination, or if you want an examination of multiple rotors in your lab, it's well worth the time to schedule a FRIP.
Great. Nate, were you going to jump in on that?
Yeah, just to chime in, if you have some rotors and you have an upcoming service visit, just letting them know beforehand, hey, I got some rotors. Do you have time to check them out? That could, prompt them to grab the equipment they need beforehand and maybe double check their schedule in case they might have some back-to-back visits or something like that. But, if they're on site and they don't have anything, they're more than welcome to take a look at the rotors, and we be more than welcome to help you.
Yeah, I think that's great. I think, again, to the degree that you can let people know before they show up, then they'll, like you say, they'll have the right stuff, but they'll also have the time in their schedule. Because I'm sure, right, they get booked out pretty good. So, okay, it looks like we just have two more, and it's only 10:36, so we'll all get an extra few minutes to our day here in a bit. Um, let's see, do newer centrifuges automatically log cycles and G-force based on serial number? Is this information available at the machine?
Absolutely. So I would say that it depends on the specific centrifuge. Some of our centrifuges are capable of logging the run count with the instrument serial number. The Avanti JXN is one such example of that. But you would need to refer to your specific centrifuge operating manual to determine if that's a feature.
Okay. And are the manuals are available online, or if they reach out to their local rep, they can get a manual if they can't
Correct.
find it online? Okay, great. And then last but not least, do you recommend leaving centrifuges open or closed when not in use? And does that answer change if we need to store the rotor in the centrifuge?
Absolutely. I would typically recommend that if you are storing a rotor in the centrifuge, that the centrifuge is cleaned to the best of your ability and left open to allow airflow and to prevent moisture buildup, especially if you're storing a rotor inside the centrifuge. If you do not have a rotor in the centrifuge, if the centrifuge has already been fully dried out after a run, etc., then it's perfectly fine to close the door on the centrifuge, just so you don't have a door flapping around. But again, it will depend on the specific centrifuge that you have, and please feel free to refer to the user manual for the centrifuge, which again can be found on our website, beckman.com, the same place that you'd go for the rotor user manuals.
Great. Well, I think that's the last question here. So I just want to say thanks to our presenters and the Beckman team for helping us put all this together. And thanks to everybody who signed up and came, and be looking in your email for a follow-up with some additional resources. And don't hesitate to reach out if you have additional questions. Thanks again, and hope everybody has a great day.
Excellent. Thank you, everyone, and thank you for all of your questions.
All right. Bye.